Okay, good morning everyone. Today I am going to discuss about the computer network subject unit 4. Coming to the topic transport layer service. Okay, so in the unit 4 I am going to discuss about the transport layer service. So what is the main use of transport layer service? Before going to explain this, just we are explaining about the introduction of the transport layer service. Okay, so the network layer, how the transport layer service is developed. So it is developed as per the network layer. Network layer provides end to end. Network layer provides end to end packets delivery using datagrams over virtual circuits. The transport layer builds on network layer to provide data transport from a process on a source machine to a process on destination machine with the desired level of reliability that is independent of the physical networks currently in use. It provides the abstraction that application need to use network. So, okay, so whatever the transport layer service we are talking now in this unit 4, so that is provided, that is built through the network layer. Okay. So, in this transport layer service we having some entities, that is transport entity. So, it is called it is nothing but hardware and the software which make use of service provided by the network layer within the transport layer is called transport entity. So, in this we having transport service provider. What is meant by transport service provider? So, transport service provider is nothing but we having 7 OSI reference models, that is application layer, physical layer, data link layer, network layer. These are our application layer, presentation layer, transport session layer. So, we having 7 different layers we are having. So, according to these 7 layers, from first layer to fourth layer, it comes under the transport service entity. Okay. So, first layer to fourth layer, it comes under the transport layer service. First layer is nothing but application layer, physical layer, second one, third one is data link layer, fourth one is network layer. So, these are the 4 one. Okay. These are the 4 network layers comes under the transport service provider. Next, transport service primitives is nothing but, so I mean transport service user is nothing but remaining layers which is present in the OS layer, that is 5th layer, 6th layer and 7th layer comes under the transport service user. Okay, transport service user. So, the upper layers, that is layers 5 to 7 are called transport service users. So, next coming to transport service primitives. What is mean by transport service primitives? Which allows transport users, that is application programs, to access the transport service. Okay. So, that is called the transport service primitives. Okay. So, these are the different entities available in the transport layer service. Okay. So, what is mean by in this transport layer service we are using the TPDU. It is mainly used for transmission process. Okay. TPDU is nothing but transport protocol data unit, transport protocol data unit. So, while transmission of message between 2 transport entities, between 2 entities means 2 devices, you can take 2 computers. So, between 2 computers you have to provide the communication, we are transmitting the message. Okay. So, that carried out by the TPDU, carried out by the TPDU means transport protocol data unit. It transports the data, whatever the data we are sending, that can be carried by the transport protocol data unit and it can be received at the receiver side. Okay. The transport entity carries out the transport service primitives by blocking the caller and sending a packet. The service encapsulated in a payload of the packet is transport layer message for the server's transport entity. The task of the transport layer is to provide, reliable, cost efficient data transport from the source machine to the destination machine independent of physical network or network currently in use. Okay, network currently in use. So, this is called the transport protocol data unit. So, in this whatever the data we are having, the data is carried by the transport data transport protocol data unit between the two devices. So, it can be passes by the that passes the data from one node to the one device to the another device, or one entity to the another entity. So, that is why we are using the transport protocol data unit. It is important point ma. So, next coming to service provided to upper layer. So, what is mean by service provided to upper layer? What is nothing but service provided to upper layer. So, in this transport service, we are having the three types, that is SEMA, this one. So, service provided to the upper layers, transport service primitives, Berkeley sockets. Now, I am talking about the first one, service provided to upper layers. So, what is mean by service provided to upper layers? Okay. Upper layers. So, here if you see the ultimate goal, the goal of this transport layer is to provide efficient, reliable and cost efficient data transmission service to the application layer, to the application service to its users normally processed in application layer. So, what is this? Nothing but whatever the service we are provided by the upper layers. Upper layers means what? Already I told that upper layers is nothing but 5, 6, 7 layers. Okay, 5, 6, 7 layers comes under the transport application. 5, 6, 7 layers is the upper layers. Okay, these upper layers comes under the user defined layers. Okay, user defined layers. Okay, so this application layer and application layer, presentation layer and transport layer. So, okay, these layers are comes under the user transport layers. Okay. So, our main goal is transport layer is to provide the efficient, reliable and cost efficient service to the application layer. Okay. To achieve this the transport layer, to achieve this the transport layer makes use of service provided, the service provider. Okay, service provided by the network layer, the software and the hardware within the transport layer, and that does the work is called transport entity. Okay, transport entity. So, what we are saying here, so whatever the achievement we are having, the transport layer make use of service provided by the network layer, and the software and the hardware, within the transport layer does the work is called transport entity. So, transport entity means already we have learned that what is mean by transport entity. So, within the transport layer the network layer within the transport layer is called the transport entity. Okay. The transport entity can be located in the operating system kernel. Where it is located? In the operating system, it in a separate user process, in a library package bound into network applications or onto the network interface code. So, in this we are having some main functions of the transport layer include. So, in this we are having connection oriented, connectionless service implementation, next connection management, flow control, error control, conjunction control. So, these are the main functions of the transport layer service. Okay. So, next coming to diagram. This is the main diagram of the service provided by the upper layer. So, this is the host 1 and host 2. We can assume as a computer and one computer 2. I am having here application layer or session layer and transport entity and network address. Okay. So, these are the different layers I am having. So, what here I am doing? I am transmitting the data. So, according to the transport entity, I am transmitting the message. Okay. I am transmitting the message to the another host. Okay. So, application service, application and section layer, application and section layers comes under the user defined layers. Okay. And transport address of the application and session layer and network layer, network address of the network layer, both are using here in the transport entity, and I am transmitting the data, I am transmitting the message, some message to the another host, that is host 2, and according to the by using the TPDU. TPDU is a transmission of message, it carries the data whatever I am sending, that sends to the host 2. Okay. TPDU is nothing but transport protocol data unit. Okay. So, this like the network, transport and application layers. Regarding these layers, I am transmitting the data through the TPDU. Okay. This is the communication occurred between the host 1 and host 2. Okay. Next, this is the logical relationship of the network, transport and application layer is in this diagram. Okay. So, next coming to transport service primitives. What is mean by transport service primitives? So, before going to explain this as transport primitives, I having some here connection, flow control, error control, this slide. So, what is a flow control, error control? So, before going to error control, so here we are connection oriented, I am having connection less services, connection management, flow control, error control, connection control. So, similarly there are two types of transport services we are having, that is connection oriented transport service is similar to connection oriented network service in many ways. So, both cases connections have three phases, that is establishment, data transfer, release. Okay. So, addressing and flow control, addressing and flow control are also similar for both layers. The connectionless transport service is always very similar to connectionless network service. So, the bottom 4 layers can be seen to the transport service providers, and whereas upper layers are the transport service users. Okay. So, next coming to what transport service primitives. What is mean by transport service primitives? So, to allow the users to access the transport service, the transport layer must provide some operations to application programs, that is a transport service interface. Each transport service has its own interface. The transport service is similar to the network service, but there are also some important difference. The main difference is that the network service is intended to model the service offered by real networks. The real networks can lose packets of, so the network service is generally unreliable. The connection oriented transport service is contrast is reliable. So, for example, I am talking here about this transport service primitives. We are considering two processes connected to by pipes in Unix. They assume that connection between them is perfect, but they do not want to know about the acknowledgements, okay, the loss of packets, conjunctions or anything like that. So, it means what ma? I am providing the two devices, and between the two devices I am giving the connection through the pipe in Unix. So, I am assuming the whatever the connection is we have given, that is I am thinking it is perfect, but I am not concentrating or recording the acknowledgements, what are the packets losses and what are the damages occurred and any errors. So, these are not I am finding out. I am just thinking my connection is perfect or not. Okay. So, what they want is 100% reliable connection. They want only 100% reliable connection. They won't think how data is reached or not, loss of data will be occurred or not, any errors will be occurred. So, these things are not necessary to this. So, he only needs the perfect connection, 100% reliable connection. The process A puts data into one end of the pipe and the other process B takes it out by the other. The second difference between the network service and transport service is whom the service are intended for. The network service is used only by the transport entities. Consequently, the transport service must be convenient and easy to use. Okay, I am having the table here. These are the primitives. I am using the listen, connect, send, receive, disconnect. These are the different types of primitives. So, why I am using these types of primitives here. So, the server executes the listen primitive by calling a library procedure that makes a system call to block the server until the client comes up. Okay. So, when a client wants to talk to the server, he executes a connect primitive with connection request TPDU sent to the server. It means what ma? So, two devices is not in connection. So, they are in stable. Okay. They are in stable, they are not in communication. Okay. If anyone server 1 system device 1, I mean node 1 want to communicate with the node 2, he want to interact with that. So, what we are sending, I am executing first the system had to listen, whatever the procedure call I am sending, he had to listen, and he should be the client and server. I am taking the client and server. The client should be turns up. Okay, turns up. Then only he can. Then only the client wants to talk to the server, and he executes the connect primitive by using the connection request. By the connection request is sent through the TPDU sent to the server. So, when it arrives at the server, whatever the request we have sent by the client that received by the server, the T unblocks the server and sends a connection accepted. Okay. So, whatever the unblock we are having, that he stopped that and he is accepted the connection through the TPDU and send back to the client. Okay. When it arrives at the client, it arrives the reply, he is unblocked, the connection is established and the connection is established, the data now is exchanged using send and receive primitives. Okay, send and receive primitives. When the connection is no longer needed, it just be released to free up the table space within the two transport entities. So, which done with disconnect primitive by sending the disconnect request. Okay. So, disconnect is a TPDU. This disconnection can be done either by the asymmetric variant and that is connection is released depending on the other one, or a symmetric variant connection is released independent of other one. Okay. So, this is the table explanation of this table, and next coming to this is the TPDU transport layer data unit protocol data unit packets are sent from the transport entity to transport entity. During the transmission of transport protocol data unit packets are encapsulated into the network layer network layer packet payload, which is encapsulated in data link layer frames as shown in the diagram. So, in this diagram is nesting of TPDU's packets and frames. So, we are having the frame header, packet header and TPDU header. The term segment for message sent from transport entity to transport entity, the TCP and UDP and other internet protocols uses in this. So, whatever the terms we are having TCP, UDP and other terms internet protocols that uses in this term. So, segments are contained in packets. Whatever the segments we are having that contains the packets exchanged by the network layer. These packets are contained in the frames. Whatever the packets we are having that contains in the frames. Okay. So, and exchanging by the data link layer. When a frame arrives, the data link layer process the frame header, and if the destination address matches the local delivery, passes by the content of the frame payload field up to the network entity. The network entity similarly process the packets header and then passes the content of the packet payload up to the transport entity. Then this is called the explanation of this diagram, and this is the another diagram. So, in this diagram we are having a transition. So, this diagram this is the state diagram of a simple connection management scheme. Transmission label in the italics are caused by the packets arrivals. Okay. In this diagram, each transition is triggered by some event, either primitive executed by the local transport user or incoming packet. For simplicity, we assume here that each TPDU is separately acknowledged. We also assume that symmetric disconnection model is used when the client is going fast. Please note down this model is suit unsophisticated. We look this non-realistic model. Okay. So, when I am going to explain this about this diagram here when it is ideal. So, when the system is ideal. Okay. So, ideal, the connection request segment is connect the primitive executed, connect primitive executed. What I am saying, when system is ideal, I need to establish the connection between the two devices. So, ideal will be send the connect primitive execution. So, active establishment pending, then connection accepted segment received. Okay. Here connection is established and connect primitive is executed, and whatever the pending is there, that can be completed and connection request segment is received. Okay. So, this like the communication will be if it is whenever the connection is established, I am sending the connection accept segment. Okay. If the connection accept segment received, okay, when the connection is established, okay, then disconnect the primitive after communication is completed, it will send the disconnect primitive executed, active disconnect pendings, and the system will be again disconnection request will be received and the connection will be disconnected. So, this is the main example of this transport primitives. Okay. This transport service primitives. Okay. Next, coming to Berkeley sockets. What is mean by Berkeley sockets? So, these primitives are socket primitives used in Berkeley Unix for TCP. The socket primitives are mainly used for TCP. So, these sockets were first released as a part of Berkeley Unix 4.2 BSD software distribution in 1983. They quickly become popular. The primitives are now widely used for internet programming on many operating systems, especially Unix based systems, and there is a socket style application programming interface for Windows called WinSock. Okay, I am having the table here. So, in this I am using the socket, bind, listen, accept, connect, send, receive, close. These are the different primitives I am having. So, what is the use of this socket? So, first 4 primitives is list are executed in order to by the servers. The socket primitives creates a new endpoint and allocates table space for it within the transport entity. The parameter includes the addressing format to be used, the type of service desired, and the protocol. Newly created sockets do not have network address, that is called socket primitive. Next, bind. The bind primitive is used to connect the newly created sockets to the address. Once a server has bound an address to a socket, remote clients can connect to it. So, that is called bind. Next, listen. The listen call which allocates space to queue incoming calls for the case that several clients try to connect to the same time. Next is accept. What is mean by accept? The server executes an accept primitive to block waiting for an incoming connection. So, these are the 4 primitives execute by the servers. Next, the client side primitives are connector. Connect primitive blocks the caller and actively starts the connection process. When it completes, the client process is unblocked and connection is established. Next, both sides we use send and receive to transmit and receive data over the full duplex connection. The connection release with the sockets is symmetric. When both sides are executed a close primitive, the connection is released. So, this is called the different primitives we have used in the Berkeley sockets. Okay, next, coming to elements of transport protocol. What are the elements of transport protocol? The transport service is implemented by the transport protocol used between the 2 transport entities. The transport protocol reassembles the data link protocols. Both have to deal with error control, sequencing and flow control, among other issues. The difference transport protocol and data link protocol depends on the environment in which they are operated. Okay. So, the difference are due to major dissimilarities between the environments in which the 2 protocols operate. So, in this data link layer, 2 routers communicate directly via physical channel, whether wired or wireless, whereas the transport layer, this physical channel is replaced by the entire network. This difference has many important implications for the protocols. Okay. So, in these elements of transport protocol, we are having some types, that is addressing, connection establishment, connection release, error control and multiplex error control, flow control, multiplexing, crash recovery. So, these are the different things available in the elements of transport protocol. Okay. So, coming to the first one, addressing. What is mean by addressing? When an application, that is user process, wishes to set up a connection to a remote application process, so it must specify which one to connect to. The method normally used is to transport address to which process can listen for connection request in the internet. These endpoints are called ports. These are 2 types of access points we are having. TSAP, that is transport service access point, mean that a specific endpoints in the transport layer. The analog endpoints in the network layer addresses are not called as a NSAPs, network service access points. IP addresses are examples of NSAPs. Okay. So, in this I am having the diagram addressing. So, this is the diagram. So, in this I am having host 1 and host 2, here application process, here server 1 and server 2. So, in the application progress, both clients and server, both client and server can attach themselves to a local TSAP. Client and server means, so in host 1 and host 2 we are having client and 2 servers here. So, those are connected to the TSAP. TSAP means transport service access point. To establish a connection to a remote TSAP. So, in order to establish a connection, we are going to establish a connection, we are sending this connection run through the, so whatever the connection we are establishing, that connection is run through the NSAP, NAS network service access point to the other host 2. So, on each host, the purpose of having TSAP is that some network, each computer has a single NSAP. NSA means network service access point. So, in this host 1 also having, in host 2 also we having. So, that can be transmit the connection through the NSAP. Okay. And so, some way is needed to distinguish multiple transport endpoints that share that NSAP. Okay. So, a possible scenario is the transport connection is follows. So, a mail server, a mail server process attaches itself to the TSAP 1522 on the host 2 to wait for a incoming call. How a process attaches itself to a TSAP as TSAP is outside the networking model and depends entirely on the local operating system. A call such as listen might used, for example, an application process on host 1 wants to send a email message to it, attaches itself to TSAP 1208 and issues to connect the request. The request specifies TSAP 1208 on the host 1 as a source and TSAP 1522 on the host 2 as a destination. This action ultimately results in the transport connection being established between the application process and the server. The application process sends over the email message, the mail server responds to say that it will deliver the message, the transport connection is released. So, this is the working of this diagram, explanation of this diagram. In the next in the next section we will discuss next topic, that is connection establishment, and okay. Thank you, ma. Thank you very much.